Hello everyone, welcome to the Golang interview question series 4. In this session, I will explain the questions highlighted in my screen here. For each of the question, I will first explain the theory part, then I will explain the same via the program, and finally all the programs that I will show you here can be found in the GitHub link provided in the description. Now let's start with the very first question that says, what are function closures or anonymous functions in Golang? Functions that execute by itself without a callee are called anonymous functions, and they are mainly used in the dynamic programming. Now let me show you programmatically what exactly I meant by that. You see here I have written anonymous function starting from line 29 to 31 is the anonymous function, and the syntax of anonymous function is func, then there is a bracket, then curly braces open close, and after that there is a bracket as well. Now this bracket means that it is an anonymous function. So now let me show you what exactly I meant by when I define or have told you about the definition of the anonymous function. Now you see from here, this function will be called, this is an anonymous function example. And inside this anonymous function example, we have written another function, but and inside that function, I have told to print, hi, I am an anonymous function. So this function does not require a callee because it's an anonymous function. So that means as soon as I will call this function, then this will should be printed. Now let me show you via example. You see, it has printed, hi, I am an anonymous function. Let me show you via one another way. Now let me stop this anonymous function call from here, and I will directly print this anonymous function here. The output will be the same for you. It has again printed, hi, I am an anonymous function. So this is all about anonymous functions. Now let's come to the second part of the question that says, can you format the string without printing in Golang? Yes, absolutely we can. We can do that by using a function of the format package in the Golang standard library actually. Now the fmt.printf function formats the string and returns the string without printing it. Let me show you via an example. So here I have written a function called format string, and I am calling format package printf method where I'm saying name is %s. Now this %s is means that I will format string here, and I want to replace this percentage string with the first value of this string that will appear after comma. So now this will return name is Mark, and this fs, this printf do not print anything to the console or to the standard output, similar to how printf function does. So what it will do is it will return the string after formatting the string based on the format that we have given here. So this function has the value of return type of string. Now let me call this function here and let me print the formatted string for you. So what I'm doing here is I'm printing the return value from the format string function to the console, which essentially it should be name is, and it should replace percentages with mark. So output will be name is mark. You see, the output is name is mark. So this is how we can format a string without printing in Golang. Now, the third question is an excellent question that says, what is a type assertion in Go? Now, type assertion allow us to access the data and the data type of the values stored by the interface. When I say interface, I essentially mean it's an empty interface. Now, let me explain what I meant by that. You see, here I have returned a program that about the type assertion, and here I'm saying that I am declaring a blank interface and assigning a value to it. Now let me do it like this. I will say I equal to this. Now in line 40, I have created a blank interface, and now in line 41, I am assigning a value to this interface. Now, since the value that I have assigned to this interface has become is of type string, that simply means that this interface internally has started managing the string type of value. Now, what I will do with type assertion is I will pull out the value of the string that I have pushed into this interface using type assertion. And what's the syntax for this is name of the interface dot the type that I want to pull out of the interface. Now, what it will do is I'll say interface dot give me the string value that you contain, and it will give me the value of the string that is hi guys. This actually is type assertion. Now it says if I will print it down to fmt.println.s, it will print hi guys. Now there is another way as well. Now this way says, okay, when I will pull out the value for you or any type of value from you from the interface, I will give you two outputs. The first output, I will give the value, and in the second output, I will give you a boolean stating true and false whether I'm able to give you the value or not. Say, for example, I will say pull out a value of integer type from this interface, and this interface do not contain an integral value because this interface contains a value of a string type. So if I will print integer here, so it will say s with a zero value and okay with false, that I am unable to give you that value because that value does not exist. Now the case that I've explained you here is being done here. The only thing is it's float 64 instead of integer. Now, in this case, I am explicitly trying to pull a value from the blank interface that actually do not exist, and I'm taking the conversion output in a variable called OK that state whether the output interface is being able to pull the value or not based on true and false. So this may have been given based on the thinking that we may have to write certain logic. If the interface is able to pull the value, then do this. If not, then do this. Now, if we do not want a scenario like this, then we can have our program to panic in case if in case the interface is not able to give you the value that you are trying to access from it, right? Now, if here, how to do that? If here, I will not ask the interface to give me a value, whether the interface is able to give me that value or not, then in this case, it will directly panic. It will say that, okay, I am of type string and you're asking an information of about float 64 from me that I do not have. And it will panic internally. That means it will exit my program with a status code of 2. Now let me first comment this part and show you by running this program here, type assertion to you. Let me comment it. Let me run type assertion here and let me say go run main.go. You see it says hi guys in the first line because I'm printing the value of string. In the second line, same I'm printing the value of the string, but with a value that says whether the pull is successful or not. It says yes, I am successful. Now let me comment this part for you and uncomment the second part for you. Now it says I am an interface of type string, but I want to pull a value of type float 64. Now let's see what output it will give. It will say 0 and false because it is defaulting the value of f to 0 that I don't have anything. I don't have float because I am an interface that has been given a value of type string. Now in OK, it says false. That means I'm unable to give you the value because I do not have, I have only string value. So this is how we can avoid panic in the type assertion. Now, if you want your program to panic in case interface do not have that type, then you can avoid having this. Okay. Now here, if you see, it will panic because this interface you see, is containing a string value, and I am asking this interface to give me the float 64 value. Let me show you by running the program. You see, it says panicked with an access status code of 2. And the error it is giving is public interface conversion. Interface is a string, not a float 64. This is all about the type assertion. Now let's come to the next question that says, what is the use of type assertion in Golang? Okay. So now as we have seen in the last question here, the type assertion is nothing but inserting the values and the type to an empty interface, right? Now, what if I have an empty interface? That empty interface can accept anything, right? And it can accept any data type. Now, what if in my program, first I have told this I to have an string value, and then I am having this to accept an integer value. So it will accept everything, right? And it will not even give me an error or a panic when I try to pull out anything from this. Right? Now, this will create an ambiguity and the runtime errors in my program, right? Because in my interface, what exactly I'm doing is I'm storing a value of different types. Now, This empty interface has a property that says, okay, if at first I am giving this interface as value of a type string, that means this interface will become of a type string. Now in the next line, if I will give it a value of integer, now this interface will become of type integer. Now that means this line will panic in this case, and this panic will happen at a runtime because these values are changed now in the empty interface. Now let me show you what exactly I mean by that is, and if I run the program, you say my program has panicked, and why it has panicked? It says interface is an int, not string. Why it is an int? Because the later value that I passed to the interface is integer, and I'm trying to pull out a string value out of it, right? So now, in case when an interface is storing both the values or multiple values, sometimes this may create an ambiguity on what data that an interface is holding. Now, to remove this ambiguity, we use type assertions. That means this is the use of the type assertion. Now, let me come to the next question quickly here. The next question says, does Golang support automatically all implicit typecasting or type conversion? The very simple answer to it is no. Golang does not support automatic type conversion or implicit type conversion, even if the data types are compatible. The reason for this is strong type system of the Golang, which does not allow to do this. Now, for type conversion, we must perform explicit conversion. Now, let me tell you of what exactly I meant by explicit conversion. So here I have written a program for type conversion where I'm saying there is a variable called total sum. This its data type is integer. Then there's a variable called number. Data type is integer. Now I want to pull out an average out of it, but I want the average in float 32. Now, if I will say, if let me comment it first. Now, if I will say average equal to total sum, I don't want to do it as a float via number. You see, it is giving me an error. It says cannot use this value of type int as float 32 value in the assignment compiler because Golang is strictly type and it will not allow us to implicitly typecast a variable. This feature is available in many other languages, even those in the languages, those are statically typed, but Golang does not allow it at all. Now, if I want to pull a value out of this arithmetic operation to a variable that is a float, so either I have to convert these variables to float, or I have to make this variable as integer because these are the integer type. Now let me show you by running the program. So here, due to the strict type checking in Golang, what I have done is first I have converted these variables to float 32, both of them, and then I have taken the average out of it because an variable with float 32 type will hold only value of the float 32, nothing else. Now let me run the program for you here. Let me comment it and run this program. It will run successfully. It says average is this. Now let's come to the next question that says how to set a variable type at runtime in Golang. Now there are many ways, or I say there are three ways to find the type of a variable in Golang. That is, we can use reflect dot type of function. We can use reflect dot value of dot kind function, and finally we can use the percentage t with a printf function. That is, we can use the formatting. Now I have written an example for you here for that. So this is a variable type. So I have created 5 variables. One is string, integer, float, slice, and then it's a map. And the first way is I am using the printf function. I'm saying the formatter. I'm saying tell me the type of this variable using percentage %c. This is the first way. The second way I'm using reflect dot type of. I'm saying okay, give me the type of the variable. This is how. Now the third way is I'm using reflect dot value of where and the kind of that value. So first give me the value of the variable, then I tell me what is the kind of that variable. That means what is the type of this variable. So these are the three ways through which you can identify a variable type in Golang. Now let me show you by running the program or running this function of what it will give you. Let me comment it out and I will call this function. I will say go run main.go. You see, it has told me this is the first type. It says it is string, it is integer, 3 is float, 4 is slice of string, 5 is map of integer and string key value pair. Now the same output second method has given and same output third method has given. Now let's jump into the next question. Now the seventh question says how to compare two structs in Golang. That's pretty easy in Golang that we can compare two structs using an equal to operator. That's very easy, but a condition should be there. A condition is there, that is the struct should not contain any functions, map or slices. If your struct is containing function, map or slices, then you have to write some custom logic to compare those things. Else if your struct is not containing function, map or slash, then you can use equal to operator to compare the two structs, and you can also use a method called deep equal. Now let me show you programmatically. Here, what I have done is I have declared a struct. The name of the struct is author, and I'm saying name, age, and date of birth. Now here I'm assigning a value. Basically, I'm initializing that specific struct. I'm saying A1 and having a value of that. Then again, I'm creating an instance. I'm saying A2 and passing the same value to that struct. So there are two variables that I've initialized and have given the values exactly the same in two of the variables of this struct. And now here I'm saying if A1 equal to A2, then print struct is equal as struct is not equal. Now let me show you here. So here you can see that everything is same among this, and I'm just using an equal to variable, equal to operator, and there are no function, slice or maps within this struct. So let me comment here. Let me call this and I'll say go run main.go. It says A1 is equal to A2. Now let me quickly do one thing. I'll go here and change the value of this struct to 31. So now these are not equal. It will tell me it is not equal to struct. Now the other way to compare a struct is not this. The other way is to use reflect.deep equal. So this method, what it does is deep equal reports whether x and y are deeply equal, defined as follows. Two values are identical type are deeply equal if one of the following cases applies. Value of the distinct types are never deeply equal. Array values are deeply equal when their corresponding elements are deeply equal. That means each and every element of the array should be deeply equal. Struct values are deeply equal if their corresponding field, both exported and unexported, are deeply equal. So since these structs are equal, so it will give me an output of true. So this function will return either true or false. You see, it has returned true. So these are the two different ways through which you can identify whether the structs are equal or not, or these are the ways through which you can compare two structs in Golang. Now let's come to the new question, that is how to compare two maps in Golang. That's also very easy. We can compare the two maps in Golang using maps.equal to function that comes with the package of map within the Golang itself. So this is the library, or this is the package that will basically contain the function to validate the equality of two of the maps. There is no condition with the map for equality like it is in struct. Now let me show you by example. So here I have created two maps. One map is this, other map is this. Both maps are of type string as key string value integer, key string value integer, and both maps are containing exactly same value. Here I'm just saying map dot equal, and then I'm passing the variables values to it. If the maps are equal, it will give me the value as true. If not equal, it will give me the value as false. Now let me show you via program. Let me comment it and I'll run the program for you here. I'll say go run main.go and you see it has given me true. Now in the map, what I will do is I will make them unequal and I will pass it as 3 to you. Now it will give me a false value and because the maps are not equal. Now let's come to the next question. Now the next question is, can we have exceptions in Golang? Now the simple answer to it is no. Golang does not support exceptions, but it has its own way of handling it. That is with defer, panic, and recover. So Go do not, which I believe Go do not have exceptions since Go developer believe it that it is not needed. Since coupling exceptions to control structure as in try, catch, and finally block result in cumbersome code, and it also encourages programmer to label ordinary errors such as failing to open a file as exception. So basically, they'll give much and much more importance to the very ordinary program using exception that logically it should not have been given to. Now, rather Golang has a multi-value return that makes to report error easy without overloading the return value for the plain error handling. And these error values are used to indicate the abnormal state in Go. So let me tell you programmatically of what exactly I meant by this here. I've written a program called error handling here for you. So what exactly I'm doing here is I'm trying to create a file called test.txt, and this function will return two things. One is a pointer to the file that I have created and the other is error. That means that the first one is a pointer to a file if I want to do any further operation with the file that I have created, and the other one is error. So I marked it as dash because I do not care about it, at least for this program. Now error I care about it. I have just told my program to have the value of the error here, whatever this function create will return. Now if function has executed successfully with no error internally. So this error value will be nil. And if there is an error within this function, then that error information will be present in this error variable. And in the next line, I'm checking if error is not equal to nil, then print whatever exactly error is now. So at first, this program will execute successfully because it will create this file in the root of my application. So let me show you by running it, and let me here fmt.println, I'll say file created, and let me go and run the program. You see it says file created. Now let me do one thing here is, let me give it a path that actually do not exist. Now, what will happen in this case is, now in the previous case where it has says file created, what has actually happened is, it has created the file and it was able to create the file successfully at some path. So the error was nil. So nothing happened. The control flow does not change. Go here and it prints file created. Now, in this case, this path actually do not exist. Now, what will happen is, it will give an error. So this error variable will not be nil. And I am saying that, okay, if it is not nil, then print everything here and tell me what exactly has happened. Let me run the program for you now, and you see it says open this, the system cannot find the path specified. It has given me an error. Or instead of this, I can say panic. That means exit my program with an error code of 2. Or I can say fatal. That means exit my program with an error code of 1. So let's use panic here. You see my program and exit within status code of 2, and it says the system cannot find the path specified here. So this is how error handling is done in Go. Let's come to the next question. So that says, what is a defer and a panic in Golang? Now let me explain you here. Now, defer moves the execution of the statement to the very end inside the function. Let me tell you what exactly I meant by that is. Now I have written a program for the defer here. Now see in is here, in line 152, I'm saying defer. And 153, there is no defer. That means as soon as the control will come to line number 152, it will see a defer and it will say, okay, under the scope of this function, the statement with defer is this, and this is the statement that I have to execute in the last. It will print hello first, and once the control is okay, after this, the function scope is terminating. That means I have to print this. So then it will print mark. So this is what exactly the defer do. Now, in case of multiple deferred statements, right? Can we have multiple deferred statements in a single program or a single function? Yes, we can have. Now, in this case, what will happen is the program will execute the statement with the defer in a reverse order in which they are deferred. That means they will follow a LIFO order. I have written a program here with a multiple defer statement. So what will happen is it will say defer, it will say, okay, I will execute in the last. Says defer, it says, okay, I will execute in the last. Okay, I will execute in the last. There is no defer, so it will execute. And after this, it will follow a LIFO approach. First in, what was the first? This one. It will print this. It will print this, and this will print this. So this is what happens with the defer. Now let me run the program for defer first for you, and then I will explain about the panic to you. So let me run defer. Comment this, and then defer. It will print hello mark, right? Because it is deferred, so it will execute it in the last. Now let me execute the multiple defer for you. So what it will do is it will follow LIFO. First will I print this, and then this, and then finally this. So see, hello, my name is you. So this is all about defer and how defer behaves in Go. Now let's talk about panic. Now panic function in Golang is similar to raising exception at runtime when an error is encountered. So whenever we fire panic function in Go, that simply means that we are telling a program to exit and with an status code of 2 with respect to the operating system. Now panic can be raised in two ways. It can either be raised by the program itself when an unexpected error occurs, or the programmer can throw the panic on purpose for handling specific errors. Now let me tell you what exactly I meant by that. So here I have written a program. So in this program I have created an array of type string with 3 values. Now if in this program I will try to, let's see like this. So from here I'm trying to print the value at the first index right now, right? So let me show you here by running it. So here it will print index 1, that is, it will print B. Let me show you here. You see it has printed B here. Now what if I want to print a value of index 5? It will not print anything. This line will create a panic because the array index is not till 5. The array index will stop at 2 because the length of this array is 3. This is a panic, and this is an programmatically program pan. You see, if I'll go here, it's an invalid argument index 5 out of the bound. Let me show you here. This will, while compiling or while running, it will give an answer. It's an invalid argument index 5 is out of bound, and 0 to 3, that means the array index started 0 and it will go till 2 because C is always exclusive, not inclusive. Now there is a custom panic that our programmer can, how it can do it is by using the panic function. Though this is not a very logical program that I have written here, but the purpose is to make you understand how we can raise panic and what exactly panic is and how we can raise custom panic. So here I'm saying age is 75, that I'm saying if age is greater than 17, then panic age cannot be greater than 70. And when I say panic, that means this program will exit with a panic information and will give pass and status code of 2 to the operating system. Let me show you by running this what exactly I meant by this. Let me comment this and let me call this function for you. I'm calling custom panic function this time. You see, it says panic. That means the program has exited. Age cannot be greater than 70. It has printed the output and then it is saying, okay, where exactly panic has happened. And it has passed the exit status of 2 to the operating system. So basically, this is all about the panic in Go. So similar in panic, what we can do is we can have two types of panic. One can be the panic that program in case of unhandled exception will raise, and there is a panic that a programmer also can raise based on the conditions or the requirements that he may have within the program. So everything related to the program that I have explained here can be found in the GitHub link that is present in the description. That is all about this session. Please do like, subscribe, and comment if you really like my videos. Thank you very much, guys.